All right, well, hey class, I'm Andy, one of your classmates, and my chemistry project was to test to see if there's a relationship between the rebound of a ball that's dropped and like a string's ability to stretch back into place. And so I went about this by obviously dropping a ball onto some tennis strings. As you see with my different strings, I recorded the heights. They're all roughly in the 71 centimeter range. And then after that, I used some of the leftover string, draped it over a little, I don't know if you call it like the bench press weight holder, the weight bench, call it that. And I stretched it over that, put a 10-pound weight on it, stretched it for 2 minutes, and then recorded how far it stretched. And that's this table. So that's how I went about getting all my data. And then, so as for results, you can see that as my rebound height decreased, it turned out that like the stretch distance also increased, so that means it did not stretch back into place well. So I'll explain it. These are more multi-filament, softer strings that people put in their string for, or in their racket for comfort. And so it pretty much goes comfort into rigidity, if that's a word. And so the balls bounce less when it's less rigid. It'll be a more durable string and it hurts. So then it also means that those strings don't stretch back into place well. So that's pretty rad. That was my world-changing discovery. Turns out if a string is stretchier, it'll bounce the ball higher. But then, as to change the world in the future, if I was able to do my original project of finding the chemical composition of each string, there's a chance I would have been able to find like an individual monomer that would be able to, like, I could link it to the elasticity of a string.